Another example of logic gate is a NOR gate. So this is a negated OR gate. So what we have here is a truth table that shows the two inputs, A and B. So here we have two inputs, input A and input B. And we have one output marked on this diagram as a C output. And if you recall, an OR gate or OR logical function would take two inputs and convert them to an output using the logic that only when both signals are 0, then the output is 0. In all other cases, the output is 1. In a NOR gate, the situation is reversed. So only when two of the inputs are set to 0, the output is 1. So basically, this is an inversion of an OR logical function. In its implementation, NOR gate takes two inputs, and you can see that two of the transistors here in parallel are grounded over here to grounded, and two other transistors, which are P-type transistors and N-type transistors. These two transistors are connected sequentially, and they're connected to the wire that has a higher voltage, 2.9 volts, whereas ground is 0. And if we follow all the possibilities of inputs at A and B terminals, which could be 0, 0, 0, 1, 1, 0, and 1, 1, we can follow the logic and discover in every single situation that the behavior of these transistors, which are simply the switches which open or close the circuit inside of them, will produce these outputs. And so this is the implementation of a NOR gate. One thing to remember about understanding the behavior of these gates is that the inputs of the gates are always clearly marked, and we never expect any sort of output on the side of on this side. So once again, these are the inputs right here. A and B are inputs, and C is always the output. So we're not expecting in any case that a signal somehow supplied otherwise from other sources to this terminal will be affecting this circuit or this gate, and partly because you can see that connection of our output is not made to any gate terminal of any transistors. These are connections to the drain and the source of P and N type transistors. So basically, we always view gates as one directional devices. So we have some inputs right here. These are the inputs, and there could be circuits that have multiple outputs, but gates typically have just one output signal.